If you haven't already printed off these notes for Chapter 8, there's a lot of definitions. I would pause the video right here and print those out. They're in the module. We're going to go over some basic definitions first. You don't have to write all what I'm saying down right this minute. I just want to give you an idea about the difference between point estimate, confidence interval, etc. Now, in this lesson 8.1, sigma is going to be known. Now, that's going to be different in another section. So we will know sigma. So there's a particular formula for that. It's given on down the page. A point estimate, the definition of that in this section is a single sample statistic. For example, let's say I was interested in the GPA of all EMCC students, and I went around and took a sample of students and just did their GPA, and let's say I found out it was 2.80. That's a point estimate. And I might say, okay, well, I took a sample, so based on the sample, I think the students at EMCC, have an average of a 2.80. Well, that's not very accurate. So what we do, since we're taking that single sample, is we give a confidence interval estimate, which is a range of numbers. Okay, so it might be more accurate for me to say, well, based on that one sample, I think my population mean of the GPA maybe is somewhere between 2.85 and 2.75. And these intervals I can give them with a certain amount of confidence, and we'll be going over that. So we are going to be looking at different confidence levels here. Okay, so we're going to look at the confidence of correctly estimating the value of mu, like for example, the GPA. We're going to construct it such that the probability that the interval includes the population parameter is known. So for example, if I have a 95% confidence interval, I'm 95% confident that the actual population mean is between the two numbers I calculated. And our answers are going to be between, again, a lower and upper estimate. Now, our general formula is going to be the point estimate plus or minus your critical value, which is Z. So we will need a Z chart. If you don't have that, you might want to pause and print it. And our standard error is going to be sigma. Again, you're going to have to be given sigma here over the square root of n. So the size of the sample does matter. So if we just go on down here and look, what we're going to do to get that interval is we're going to take our point estimate, our sample mean, plus or minus our Z value, our critical value, and I'll explain that alpha over 2 in just a second, times sigma over the square root of n, and that's going to give me that interval. Okay, now typical confidence levels are 95, 90, and 99. You can never be 100% confident. And how our samples would vary from sample to sample is called our sampling error. Now our confidence level is symbolized by 1 minus alpha times 100%. Okay, so let's talk about alpha here. Alpha, and you might want to write this down, is the proportion of the tails outside the confidence interval. Okay, so let's say we want to find alpha when we have a 95% confidence level. Remember, the area under the whole thing is 1. Let's say that this contains 95% of my values. Well, alpha would be 1 minus 0.95, which would be 0.05. So the two tails together have an area of 0.05. And if you'll recall from previous problems where we had two tails, and of course they're the same size, we would take the 0.05 and divide by 2. That's why we're finding z at alpha over 2. Okay? So let's say we wanted to find z for the 95% confidence interval. Well, we've got z, alpha is going to be 0.05 over 2, which is z at 0.025. That's 0.025. I'm just going to put an extra 0 there. And we find z using our z-chart. And so let's go over here to the negative side, because that would be for the lower tail here. Remember, it's always going this way. And this area here is 0.0250. 0.0250 goes with a z value of negative 1.96. Now notice this formula includes the plus or minus, and so our z values for a 95% confidence interval are going to be plus or minus negative 1.96. If the lower one's negative 1.96, this is the same distance over, and it would be positive 1.96. Okay, and that's something that we're going to want to have handy when we're doing our homework or taking a test, because 95% is a very common confidence interval, and so are these, and we'll be writing those down. Okay, so here's our formula here. Here's our z value. Again, the lower tail, that's 0.025 as far as the area, and that was a negative because we're on that side, 1.96, and we know that if we get the positive, the area from here down would be 95% plus 0.025, which would be, what, 90.9750. Well, just so you trust me here, 0.9750, again, is positive 1.96. Okay, so we're good here. Now, we have to assume in this section that sigma is known and the values are normally distributed. Now, here are the common ones here. And let's just go ahead and make a note of those values since we're going to use those so many times. Okay, for 90%, it's plus or minus 1.65. Excuse me. Promise I'm not sick. For the 95%, it's 1.96, and 99% is 2.58. Okay, these values you want to have written down somewhere handy. Okay, now here's a problem. We have a sample. It tells us it's normal. The sample mean is 2.20. We're given sigma. Again, in this section, we have to assume that we know sigma. That is the population standard deviation. Let's see, n was 11. And our z for this size confidence interval, we'll say it's z at alpha over 2 because we have two tails. For 95% is 1.96. Okay, so to make an estimate from u, we're going to do x bar plus or minus and that will be our setup there. In this case, x bar is 2.20. There's our z, sigma, and n is 11. And I went ahead and got a decimal for this in my calculator. And I'll take that out to a few decimal places. So let us know in the homework what they want us to do as far as decimal places. So to get my upper value, again, we're saying that mu is between an upper and lower value. If I add those on my calculator, I get this number. If I subtract them, I get 2.1823. And what I'm saying is I'm 95% confident that this range contains mu. So I'm making an estimate about what my population would be based on my sample. Okay, we've got a couple more examples to do. So if you will go to the second part of this lesson, 8.1.